Alright, let's take a look at number 8, and this is a problem where they want us to write a formula that would be able to predict or be able to give us the derivative, the nth derivative. So for instance, we might want to know the 43rd derivative of this function, and instead of taking the derivative 43 times, there has to be some sort of pattern that's formed here. So let's take a look and see if we can maybe develop the first 2 or 3 derivatives and see if we can see a pattern developing here. So first thing I want to do is rewrite the original function. Well, x plus 5 is in the denominator, so I can bring it up to the top by making it to the -1 power. And so if I do that, maybe taking the derivative will be a little bit easier. So the first derivative of x is equal to what? Well, this is just a chain rule. You have something raised to the -1 power, so we're going to use the power rule. So we have -1 times the blah, or the inside stuff, and then it's to the -1 subtract 1 power, so we have -2 power. And then let's just go ahead and take a look at the second derivative. And the second derivative, that -1 is still a constant out here. So the derivative of the second derivative would be times -2 to the x plus 5, and now we're going to subtract 1 from our -2 and get a -3. And then let's go ahead and do it maybe for the third derivative and see if we can develop a clear-cut pattern here. So in the third derivative, we still have our 2 constants, -1. We have our -2, that's still a constant. And now we're going to actually take the derivative of this part right here. So we have -3 x plus 5, and decreasing that -3 or subtracting 1 from -3, we get to the -4th power. And then of course the derivative of the inside quantity is just 1, so that doesn't change anything. So let's look at it and see if we can develop some thoughts here. First of all, this derivative is negative, and this derivative would end up being what? Positive, right? Because you have negative times negative. And this derivative is a negative times a negative, which is positive times another negative. So the third derivative is negative. So it looks like this thing probably alternates between negative to positive, negative. So how do we express that? Well, if we take -1 and raise it to the nth power, and n is equal to numbers like 1, 2, 3, ... right? So if you plug in 1, you get -1 raised to the first power, which is -1. You raise it to the second power, if n is equal to 2, negative times negative is positive. -1 raised to the third, give us our negative. So that takes care of the rule for alternating between positive and negative. So this causes me to alternate from positive to negative. Okay, so let's write that down. So we have -1 raised to the nth power, and this of course is the derivative to the nth power, I suppose, or the nth derivative. Well, what else do we see? What other patterns do we see here? Well, this one's multiplied by -1. This is 1 times 2. And this is 1 times 2 times 3, right? Well, hopefully you remember that this is just 3 factorial. 3 factorial is equal to 1 times 2 times 3. 4 factorial is 1 times 2 times 3 times 4. So here we're on this is the first derivative, the second derivative, and the third derivative. So when I'm on the third derivative, my answer is negative, so that would be a 3 there. And when I'm on the third derivative, it's multiplied by 3 times 2 times 1. We've already taken care of the signs, right? By this guy right here. So this is in factorial, which is the exclamation point. And the rest of the function is just x plus 5. So if I'm on the third derivative, what does my exponent equal? Equals negative 4. If I'm on the second derivative, it equals negative 3. So if I have a negative n, subtract 1, that should satisfy the rule. Now the way to check this is just to go ahead and calculate the second and the third using the rule that you just developed. So to find the second derivative, this is just a way to check it here. To find the second derivative, n would equal 2. So let's plug in n equals 2 every time we see n in our formula that we just created. So we have negative 1 to the second power. N factorial is 2 factorial. X plus 5 doesn't change. And then we have negative 2 minus 1 power. So let's see, negative 1 squared is positive 1. And we have 2 factorial, which is 2 times 1. X plus 5. Negative 2 subtract 1 is negative 3. So the second derivative should equal this. Well, all of this is just 1 times 2 times 1, which equals 2. X plus 5 to the negative 3 power. So let's go back up to the top here, and let's examine our second derivative. Our second derivative, if you multiply negative 1 times 2, you get positive 2. And that checks out. And then x plus 5 to the negative 3. And we have x plus 5 to the negative 3 up here for the second derivative. So this is your rule for the nth derivative of our function 1 over x plus 5. Okay.